Okay, we're going to talk about the concept of stoichiometry. Stoichiometry is a calculation based on a chemical reaction. Now, when we write a chemical reaction in chemistry, we want to make sure that we have a balanced chemical reaction. So let's take this reaction. CH4 plus O2 gives us CO2 plus H2O. We've got one carbon on both sides. We need to put a 2 here so that we balance out our hydrogens, and a 2 here that we balance out our oxygens. Now, when we look at stoichiometry, we can look at it in terms of a way to convert from grams to moles to moles to grams. So, let's say I have 56.6 grams of methane, okay? And I'm kind of thirsty, so I want to know if I burn that 56.6 grams of methane, how many grams of water I can get from that reaction. Now, when we look at this particular reaction, we're going to presume that we have an infinite supply of oxygen, so that we have complete combustion. So, we know from chapter 2, if we want to go from grams to moles, we multiply by the factor 1 mole over the formula weight. If we want to go from moles to grams, we multiply by the factor of the formula weight over 1 mole. So, stoichiometry allows us to make a calculation based on these two relationships. So, our equation is balanced, if we remember, based on the number of moles or the number of molecules or atoms. Well, it's not based on the number of grams, so we've got to convert our grams into moles so that we can work a stoichiometry equation. So, 56.6 grams of CH4 times 1 mole of CH4 contains 1 carbon and 4 hydrogens, so that's going to be 16.04 grams of CH4 per mole. When we multiply by that, we can cancel grams of CH4, and now our units are in terms of moles of CH4. Now, from our balanced equation, we see that 1 mole of this produces 2 moles of this. So, if we want to convert from grams of this to grams of this, we have to have some type of conversion, which comes from our balanced equation. And this is called our equation conversion. There are 2 moles of H2O for every 1 mole of CH4. So moles of CH4 cancel. So now we have units of moles of H2O, but we're still trying to get to grams of H2O. So we've got to convert from moles to grams, so we multiply by the formula weight over 1 mole of H2O, and that's 18.02 grams of H2O per mole. So that's our equation. And our units would be grams of H2O. So we have 56.6 times 1 times 2 times 18.02 over 16.04 times 1 grams of H2O. Now I'm going to cheat a little bit here. I'm going to cancel out the ones. I have to get my calculator out and do a calculation here. Let's see, 56.6 times 2 times 18.02 equals, divided by 16.04, and we get, if I did my math correctly, 127.174 grams of H2O. Now, we remember that we have to look at the correct number of significant digits. We started off with 3 significant digits, so we need to end up with 3 significant digits. So, if we have 56.6 grams of methane, we can produce, if we have an infinite supply of oxygen, 127 grams of water. So we can also make other calculations based on our equation. With these calculations, if we want to know how much CO2 we produce, we can do that also. Okay, so we can start off with our 56.6 grams of methane. And we still have to convert it into moles. 1 mole of methane is 16.04 grams of methane. That will cancel. Now, from our equation, we have 1 mole of CO2 in our balanced equation. We have 1 mole of CH4 in our balanced equation. So our equation conversion is 1 mole of CO2 for every 1 mole of CH4. Those will cancel. Okay, now we need to go and find the weight of CO2. From the periodic table, it's got 1 carbon and 2 oxygens. Carbon is 12.01, oxygen is 16. So 16 and 16 is 32, plus 12.01, so it's 44.01 grams of CO2 per 1 mole. That will cancel. We have units of grams of CO2, so 56.6 times 1 times 1 times 44.01 over 16.04 times 1 grams of CO2. We cancel the 1s. So the number of grams of CO2, get out the handy dandy calculator again, is 56.6 times 44.01 divided by 16.04, and we get 155.30. We still need, what, 3 significant digits, so it's 155 grams of CO2, okay? So, assuming that we have 56.6 grams of methane, an infinite supply of oxygen, we can produce from that 127 grams of water and 155 grams of CO2. So if we're looking at it in terms of reactants, reactants would be our CH4 and our O2, and our products would be our CO2 and our H2O. So we've made 155 grams here, and we made 127 grams here. We started out with 56.6 grams here. We can find the amount of oxygen from the information that we've got, okay? How do we do that? Well, remember, our equation has to obey the law of conservation of matter. So the total amount of matter on the left-hand side, the reactant side, must be equal to the total amount of matter on the product side. So if we just sum these two numbers, we sum those two numbers, that would be the total amount of product. So 155 plus 127 is 279 grams for both. And if we subtract 56.6 grams, that would leave us with 222 grams of oxygen that's required, okay, for us to have a balanced chemical reaction that obeys the law of conservation of matter. The total mass here has to be equal to the total mass here, so that it obeys the law of conservation of matter. So if we've got 2 of the products and we're missing 1 of the reactants, we can just take some simple addition and subtraction to find the difference. So, in looking at stoichiometry, always remember that if you have a mass, your mass must be converted to moles so that you can make a calculation. You can also convert it to molecules, which would require you to carry a lot of large exponents, but it will work out the same way. It'll just be a little bit harder in the mathematics. So remember that all equations must be mass balanced before a calculation is carried out, and that mass balanced equation is balanced based on the number of moles and the number of molecules.